Hello, my name is Andrew Geary, and welcome to Seismic Sound-Off, in-depth conversations in applied geophysics. Machine learning and artificial intelligence, two of the trendiest and important topics in geophysics right now. In this episode, I speak with Aria Abubakar on his 2020 SEG-AAPG Distinguished Lecturer tour on the potential and challenges of applying artificial intelligence and machine learning methods for geoscience. This conversation explores machine learning and AI from multiple angles. What is the biggest success of AI and machine learning to date in the geosciences? How can geophysicists tailor AI, machine learning, and data analytics algorithms and paradigms to meet the specific properties of geoscience data? How close are we to transforming modern workflows from proof-of-concept works to scalable commercial products? If you are new to these topics or want to hear the latest news in this essential area of knowledge, Aria will be your guide for our current understanding as well as the future possibilities for machine learning and AI. Aria is currently the head of data science for the Schlumberger Exploration and Field Development Platform. He oversees and coordinates the utilization of machine learning and data analytics technology for exploration and field development applications throughout Schlumberger. For the full show notes and the link to Aria's upcoming tour, visit seg.org/podcast. Let's get to the conversation. The focus of your upcoming talk for SEG, it's called Potential and Challenges of Applying Artificial Intelligence and Machine Learning Methods for Geoscience. This is certainly of major interest right now, not just in the geosciences even. And before we explore your lecture a bit more, for someone new to the use of AI and machine learning in the geosciences, why is it particularly relevant? What do AI and machine learning help bring and help address in the geosciences?
Yeah, that's a good question, Andrew. There are a couple of things. The first keyword, I think, is efficiency. When we do our job, we would like to be efficient. And most of the time, our stakeholder would like to have the answer to their problem as soon as possible. And in addition, nowadays, we are always dealing with a large amount of data to be processed and used in our workflow. Hence, improving the efficiency in geoscience workflow without sacrificing the quality is very important. It will bring tremendous value. The other thing is, what I think important are also the automation and consistency. In most part of our geoscience workflow, they are very labor intensive and most of the time require a repetitive process. Such process certainly can be automated by using AI or machine learning algorithm. And in addition, if we can do all this repetitive process in a very consistent way, we will be able also to improve the quality of the result. Now, combining this efficiency, automation, and consistency in combination also with the rapidly increasing computer power, this will allow us to develop the workflow that are more efficient, consistent, and automated. And the other thing that make AI and ML relevant, if we think about our geoscience workflow, at the moment, most of the process are very sequential. In the later part of the workflow, if we have a new information coming in, or it means that we have a new data set coming in, it will be very hard to update our subsurface model, for example. Because if we manage to automate most of the part of our workflow, it will allow us to have the so-called living subsurface model. What does it mean? It means that when a new data coming in, we can update our subsurface model in a very short amount of time and in automated way.
This might be pieced in that response there, but to pull it out a little bit, what do you think has been the biggest success of artificial intelligence and machine learning to date within the geosciences?
Now, to answer that question, I think we are now still in early days. Having that said, if we look at also in the last 2 years in the SEG annual meeting, we do see that the geoscience community is already embracing the AI and ML in a big way. I think the most successful AI and ML application in geoscience are the cases where we have a sufficient amount of the data. By data, I mean both the measurement as well as the training labels. And the other workflow that quite successful, you will see, in addition to the availability of the large amount of the data, these algorithms were developed jointly by the data scientists and as well as the domain scientists or the subject matter expert. If you want to hear a specific example, I can mention a few of them. There are some quite successful work on the seismic fault detection, the seismic salt detection for velocity model building, the automation of the log QC, as well as the log correlation.
Within your lecture that you're talking about, you have several questions that your lecture is going to address. And I just want to get a glimpse of a couple of these questions for the listeners. How do geophysicists tailor the AI, machine learning, and the data analytics algorithms and paradigms to meet the specific properties of the geoscience data?
What I mentioned in here, when we apply the ML and AI algorithm or workflow to the geoscience application, we have to do it in a very careful way, and we have to build a fit-for-purpose algorithm. Let me just mention several examples. For use cases where we have a large amount of data, again, data means the data and the training label, we may want to employ a supervised learning approach. Now, when we are dealing with the use cases, when the amount of data is large, however, the amount of the training label are limited, then we may want to resort to a semi-supervised learning approach. There are also other use cases where the training label are simply not available. You can take an example here, maybe the noise attenuation use cases. Then in that cases, we will, if possible, we want to employ the unsupervised learning approach. And then you have to also look at the detail of the use case itself. If we are dealing with a high complex problem, then the ML algorithm that you design, the machine learning, if you are using neural network, you have to use a very deep network, for example. And if you are using a very deep network, this can only be done if the amount of the data and the training label are available, right? And then we have to make sure also the data contain an independent information. Otherwise, you will end up with an overfitting problem. Now, if you are another extreme cases, if you are dealing with a very simple problem, then you do not need to employ a very deep architecture of neural network, since you will waste the computational resources. In summary, what I want to say in here, that before we apply, we cannot just have one algorithm and then apply it to all of our use cases. Because we need to understand the problem and the complexity, then employ the most suitable AI and ML algorithm and design the algorithm accordingly.
I hear that term supervised learning frequently in these conversations. Could you just tell briefly what supervised learning means in the context of working with data and machine learning?
Yes, supervised learning, it means that the training process you do in the supervised way, because it means that you have the data and the label. When we say the semi-supervised one, for those cases, then you usually the amount of the available training label are limited. That's why in the most of the time you will utilize more the data. And there are another extreme cases where the training label are not available. Then you will use what we call the unsupervised learning approach.
Okay, that's very helpful. Thank you for highlighting those differences there. And in your talk, you say the most important question to address right now is how to translate these modern workflows from proof of concept to scalable commercial products. Where do you see the geoscience field currently positioned in that continuum? Are we close to building a scalable product?
Again, in this case, I think we are still in early days, although we see some recent example of success in the industry. Again, go back to SEG annual meeting, for example, right? You will see in the last 2 years, maybe in the AI and ML session, you will see almost like hundreds of papers presented about the application of AI and ML algorithm for geoscience workflow. Most of them are, you can see a lot of a good result. However, I saw also that most of them are in the stage of the proof of concept work. Before we can go from the proof of concept work to the scalable commercial product, there are quite few issues that need to be addressed. Let me just take an example. From the algorithm point of view, the question that we need to address, how we can make sure the AI or ML model that we build is robust. It means that after we train it, if we want to apply to a certain data in certain location, how do we know that this is generalized and this is applicable? And how we can QC the result without diminishing the value of its efficiency. The other question is how we can automate the retraining of the ML model. That is also one of the challenge to make a living subsurface model or how to have a very generalized ML model. On the computing part, is how we can make all these calculations very efficient. And as we know that even with the current computational resource for seismic problem, sometimes it's still very challenging to employ a full three-dimensional neural network architecture. From the user point of view, how we can tailor the workflow so that the non-expert user can benefit, not only the expert user that have a data science background. And we will need a suitable AI and ML deployment platform that can connect to existing our geoscience software or platform. Because after you run the ML or AI, you want the result to be consumed by the next step in the workflow.
A lot of fun, challenging problems to start working on and address. Do you, kind of building off that, do you think it's essential today to understand and use AI, machine learning, and data analytics to succeed in geosciences today?
The short answer is yes. I think it is yes. I think ML and AI is a very valuable tool which can be used to make our geoscience workflow more efficient. It can be used to obtain more accurate results. And it may be able to help us to open the door to get more answer to our current problem. Having that said, I will say also the AI and ML algorithm is not a silver bullet. Not all the problem need to be solved by AI and ML, or even can be solved by AI and ML algorithm.
What do you hope will be the takeaways for attendees of your lecture?
Yeah, the main key takeaway that I hope to relay to my audience is that the ML and AI is a tool for geophysicists, geologists, petrophysicists, and this tool has a tremendous value and many potential that will make our work easier. I want to also stress that not all problems have to be solved or can be properly solved by using AI and ML algorithm.
How does someone maybe new to AI machine learning understand maybe what geoscience problems aren't the best to be solved by this method?
That's why it is a key, right? When the data scientists work on this problem, they have to work the problem in collaboration with the domain expert. Then obviously then the domain expert can help the data scientist to understand what are the state of the art of the current workflow. And then the data scientist can try to identify whether this problem can be formulated as an AI and ML problem.
Kind of thinking grandiose here, finish this sentence, please. When AI and machine learning reaches its full potential, it will...
If AI and ML reach its potential, I think it could significantly reduce the turnaround time of the geoscience workflow. And then we can also be able to automate for most of the part of our geoscience workflow. This will in turn allow us to have a relatively new concept such as a living evergreen subsurface model. And I hope then at the end, this will impact how we take our business decision and bring more value.
Two questions in here that I like to ask and get from these, wide-ranging expertise and wisdom that you all bring. What is one piece of advice that you would offer someone who would like to succeed in your field?
Because I will say then have an open mind, because most of us may be used to a certain way to work. Because by augmenting our tool with the AI and ML algorithm, it may open a new way how we solve the problem or even look at the problem.
What excites you the most about working in AI and ML that excite you? What is the thing that really drives you to work on these problems every day?
The significant improvement, especially in the efficiency, how we can make, for example, a certain processing to be really more efficient, to be more accurate. And it is just amazing how we can do it if we manage to formulate the problem correctly, right? Because if I can take an example on the seismic fault detection. In the past, most of the time, this work is done by using a certain mathematical tool in our software. And it will take a person to do this in a couple of weeks. By using the ML and AI algorithm, we can push down the turnaround time from the couple of weeks into a few hours. And it doesn't require a very high expertise of the end user.
Well, perfect. I appreciate your time and your flexibility and working with me to do this interview. And we look forward to your upcoming talk in the weeks and months ahead. Thank you again for taking time out.
Thank you, Andrew.
Thank you for listening to SEG's flagship podcast. Please share this episode with a friend, colleague, or manager that would enjoy hearing this episode. Your recommendation is the single best action you can take on behalf of SEG's podcast. Go to our website at seg.org/podcast to find all our episodes and learn how you can listen to this podcast directly on your phone without downloading an app. Original music by Zach Bridges. This episode was hosted, edited, and produced by me, Andrew Geary. The SEG podcast team is Jennifer Crockett, Allie McGinnis, and Mick Sweeney. Thank you for listening. This is Seismic Sound Off, signaling off.